Section 7.2, we're going to use the converse of the Pythagorean theorem. Remember how the converse of a theorem flips the if and the then. Now, the Pythagorean theorem said if you have a right triangle, then a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, notice I flipped the way that was written there, then the triangle is a right triangle. Okay, so the converse of the Pythagorean theorem, in words, I have if the square of the length of the longest side of a triangle, c squared, which would potentially be the hypotenuse squared, is equal to the sum, or adding together, the squares of the lengths of the other two sides, which would potentially be the legs, then the triangle is a right triangle. So if this relationship is true, if I just give you three side lengths and I say, is this a right triangle or not? We'll see if it passes the test and whether one potential leg squared plus the other potential leg squared equals this potential hypotenuse squared. And why do I keep saying that word potential? Because you don't know for certain until you test this out. If these two things are equal, yeah, it's a right triangle. If not, well, then it's not a right triangle. And actually, if you think of the other triangles it could be acute or obtuse. And we can even make that determination as well based on what we get with these results. If you find that the one side squared alone, what you thought was a hypotenuse, the longest side squared, if you find that that's greater than the other two sides squared added together, then it's an obtuse triangle. And the way you can remember that is you think in an obtuse triangle, since we have one angle greater than 90, you have one really long side opposite from that obtuse angle. So if you've got one really long side, one really big number, that one number by itself squared will be greater than the other two sides together. That's how I remember that obtuse triangle has the one side squared greater than the other two sides squared added together. And the opposite is also true, that if you have the one side squared being less than the sum of the other two sides squared, then it's an acute triangle. And the reason there is, in an acute triangle, I mean, the sides are pretty close to the same length. Okay, there's not one really long side because the angles are all less than 90. So then the two sides squared added together would be more powerful than that one longest side squared. That's how I remember. But yeah, you can decide whether a triangle is obtuse, right, or acute just by testing the Pythagorean theorem, sort of, and figuring out the relationship between one side squared versus the other two sides squared added together. Alright, so let's check this out. Oh, and actually, before you even test whether Pythagorean theorem holds, remember to see if the side lengths even form a triangle. For example, if you had 5, 6, and 14, think about that. You have a side length of 14. Okay, let's say I really know this length is 14. How long is the side length of 5 going to be relative to the 14? Well, it's like a third of it or something. Not even. That'd probably be a length of 5. Length of 6 would be maybe this long, a little bit longer than that 5. And the problem is, what is 5 plus 6 together? It only equals 11, so there's no way that I'm going to make up this gap here because that bottom length was 14. And remember, the way to test that is add the two shorter sides and make sure that it's greater than the third side or the longest side. So start out, check if you've even got a triangle, because sometimes you're going to have three numbers and you're like, that doesn't even make a triangle at all. So it's not acute, right, or obtuse. It's not a triangle. So test that first. And then from there, try out Pythagorean theorem, because it'll determine whether you have an acute, right, or obtuse triangle. So let's give it a go here. Determine whether these three sides make a triangle at all. And then, if it does, determine whether it's acute, right, or obtuse. And there's going to be some with square roots in it. You know, don't let that scare you, but kind of the first thing you should do is just figure out approximately what that is as a decimal. Don't use the decimal when you do the problem, but just to get an idea, because I want to know what it is to see if it even makes a triangle. This is about 6.9, and obviously there's a million, an infinite number of decimals after that 9, but I'm just getting an idea. This is almost 7, and so it is, well, I guess 4 and 6.9 would be the shorter two sides, 8 would be the longest side. Together, 4 and 7 is 11, so it is more than 8, so it does form a triangle. And remember, you always just have to test that first. Now, to see which side squared you're doing alone, you pick the largest one. It also helps to know what that is as a decimal, because now I know that this would be the longest or largest side. So I'm going to test that one side squared alone. That might be the hypotenuse, remember, if it is a right triangle. I'm just going to put a question mark. How does this compare to the other side squared added together? So 4 squared plus 4 squared of 3, and that whole thing has to be squared. Well, let's check it out. I know 8 squared is 64. Still going to keep that question mark there. 4 squared is 16 plus, now 4 squared of 3 squared, we're squaring both of these things and multiplying them together. So 4 squared is 16, but square root of 3 squared, since it's in the square root and you're squaring, it's kind of like that cancels out. So square root of 3 squared would just be 3. So this will actually be 16 plus, well, 16 times 3 is 48. And now 16 plus 48 gives me 64. Well, look at that. If those are equal, what kind of triangle do I have? I have a right triangle, because it turned out that we did have 2 legs squared added together, giving me hypotenuse squared. A squared plus B squared equals C squared. It's a right triangle. Okay. The next triangle, I have sides of 10, 11, and 14. And first of all, does it make a triangle? Well, the two shorter are 10 and 11. That adds to 21. More than 14, so yeah, those sides will make a triangle. Now, if this is a right triangle, I pick the largest side for the potential hypotenuse, which would be 14, would be the longest side. So 14 squared, how does that compare to the other 2 sides squared added together? So 10 squared plus 11 squared. Well, 14 squared is 196. And I'm just going to do in one step 10 squared plus 11 squared. I guess I could have done that in my head, right? 100 plus 121. So 221. Alrighty. It turns out, it's definitely not a right triangle. It turns out that the one side squared was less than the 2 sides squared added together. Which means this one side was not real long compared to the others. It wasn't extremely long. So all the sides were close-ish to the same length. That's an acute triangle. Remember, it's obtuse if that one side alone is greater, because it must have been really long compared to the others. So I had an acute triangle there. Let's try out some more. I have the sides 5, 6, and square root of 61. Okay, just to get an idea, I'm not going to use this when I do the problem, but the square root of 61 I'm doing on the calculator is about 7.8. And that decimal goes on forever. I just want an idea about what it is, because that helps me to know that this is the longest side then, right? It's longer than 5 and 6. Does this make a triangle? Well, yeah, 5 and 6 adds to 11, and that's more than this 7-ish or 8-ish decimal there. So now when I try it out, I'm going to do what might be the hypotenuse, square root of 61 squared. And I want to see how does that compare to these other 2 sides, which might be the legs, 5 squared plus 6 squared. Well, square root of 61 squared, squared and squared cancel, and it's just 61. 5 squared plus 6 squared would be 25 plus 36. Hey, that's also 61. These are equal. What kind of triangle do I have? That's a right triangle if one side squared equals the sum of the other 2 sides squared. Okay, so another right triangle there. Alrighty. What about here? 11.2, 6.5, 7.1. Notice the longest side is the 11.2. The shorter 2 sides, 6.5, 7.1. I'm going to underestimate here. If this was only 7 and this was only 6, that still adds to 13. It's still more than that third side, so it does make a triangle. Now if I'm testing to see what kind of triangle this makes, the side that I picked by itself would be the longest one, so 11.2 squared would be your potential hypotenuse. How does that compare to the other 2 sides squared added together, which would be your potential legs if it's a right triangle? Definitely need the calculator here. 11.2 squared is 125.44. And then in one step, I'm going to do 6.5 squared plus 7.1 squared. and I get 92.66. Alright, check it out. It looks like this one side squared alone was greater than the sum of the other two sides squared, which means this one side must have been really long. And you have a very long side in what kind of triangle? That would be in an obtuse triangle. You have one very long side compared to the others. You know it's obtuse. Alright, for tomorrow I want you to do these last two. Figure out, first of all, do we have a triangle made there at all? And then is it acute, right, or obtuse? Based on checking the converse of Pythagorean theorem. So always testing how c squared compares to a squared plus b squared and what kind of triangle you have.